Welcome to the Crazy Hat Chemist. So here we go again with another video in bonding. Bam! So today we're determining the hybridization and bond angles for number 3. Okay, so what is number 3? Number 3 is ammonia. So before we really get moving on ammonia, that's NH3, what I want to make sure you do is review 2 videos. The first video you're going to do and reviewing is drawing the Lewis dot structures number 3 and the determination of molecular geometry number 3. From those 2 videos, we're getting this following information. In the black and white is the Lewis dot structure. That is the nitrogen in the middle, it's 3 bonding hydrogens and a lone pair of electrons on the nitrogen. You're going to get the Ax formula as an AX3E, and you're going to get 3 bonding domains and 1 non-bonding domain. And from all of that information, you should be able to get the 3-dimensional shape of this, and it's trigonal pyramidal. So what we need to do is we need to answer the hybridization and the bond angles for this NH3 ammonia that's trigonal pyramidal. Okay, and here is trigonal pyramidal. Okay, hopefully you see this right here. I am holding on to the lone pair of electrons on the central nitrogen. The nitrogen is the blue. The hydrogens are the white things here, and this tan thing here that I'm holding on to, those are the lone pairs of electrons here on the central element. You notice that this is trigonal, but it is not trigonal planar. Trigonal planar has the central element and the outside elements in the same plane, and of course you can see that that nitrogen and the hydrogens are not in the same plane, so that differentiates trigonal planar from trigonal pyramidal. This is, of course, trigonal pyramidal. Okay, and so the hybridization on this is going to be the following. We need to count the domains around the central element. So how many domains around the blue thing, the central element, which is the nitrogen? I got 1, I got 2, I got 3, I got 4. It's the same as the number in a tetrahedral structure, because this has a tetrahedral arrangement of electron domains. So for the hybridization, it's going to be S, P1, P2, P3. I'll do that one more time with different ones. S, P1, P2, P3. Notice that the lone pair of electrons count as a domain around the central element here. Okay, and then the bond angles. The bond angles for a tetrahedral arrangement of electron domains is 109.5. But because this lone pair is here, it is not localized. So these gray things here are localized electrons between the central element and the outside element. These are localized. That is, they are between the 2 here. They are between the 2. This is a delocalized set of electrons, i.e. it's not grabbing a hold of another element. So it's using up a lot of space right here. Consequently, it compresses the bond angles of all the other elements. So what I can say for sure is that the bond angles here, this bond angle, as is this bond angle, these 3 bond angles that are right here, they are less than 109.5. Now, with ammonia, it's going to be a specific bond angle that's measured at 107. Okay, so I'm going to give you that information here, right here, and we already figured out it is sp3. There are 4 domains, that's sp1, p2, p3, and the bond angle is less than 109.5, and I'm going to say it's really, really close to 107. That's anything that's trigonal pyramidal. Okay, hopefully you enjoyed that video. Hopefully you learned some cool stuff about chemistry, and here is another cool hat. Oh yeah, baby, I'm a giraffe. Woohoo! Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I'll see you next time. Bye now.